You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Document intelligence is a term that refers to the set of artificial intelligence techniques designed to interpret, extract, and make sense of complex documents. These may include scanned PDFs, business forms, handwritten notes, or highly structured regulatory filings. In essence, document intelligence transforms static content into structured, actionable data. Traditional digital systems struggle with these documents because they are often formatted for human eyes rather than machine readability. A contract, for example, might include small print clauses, multiple columns, embedded tables, and handwritten signatures. To a computer, this looks like a jumble of pixels or characters, not a coherent structure. Document intelligence overcomes this barrier by combining optical character recognition, layout parsing, and language understanding. Together, these capabilities allow systems to see not only the words but also how they are organized, what they mean, and how they connect to larger workflows. For learners, it is helpful to imagine a human paralegal reading a contract. First, they recognize the words, then they understand the sections, and finally, they interpret the legal meaning. Document intelligence does the same but at machine scale. Optical character recognition, or OCR, forms the foundation of document intelligence. OCR takes scanned images of text and converts them into machine-readable characters. Without OCR, documents remain locked as pictures, unusable for search, indexing, or analysis. With OCR, text becomes accessible to algorithms, making it possible to extract clauses from contracts, entries from invoices, or medical details from patient records. OCR is not a new technology. It has been around for decades. What makes it powerful today is its integration with modern AI systems that extend its accuracy and apply its outputs to complex workflows. OCR is the essential first step, like translating a handwritten note into typed text before analyzing its meaning. Only by making text machine-readable can higher levels of intelligence, such as semantic interpretation or retrieval, function effectively. Yet OCR faces accuracy challenges that directly influence the effectiveness of document intelligence systems. The quality of a scanned document matters immensely. Blurry images, skewed pages, or low-contrast photocopies can make recognition difficult. Fonts that deviate from standards or handwriting that is messy or idiosyncratic add further complexity. Languages with complex scripts, such as cursive Arabic or dense Chinese characters, stretch OCR capabilities even further. Errors at this foundational stage cascade upward, meaning that if OCR mistranscribes a number or name, every subsequent step risks being flawed. To mitigate this, modern OCR systems combine image pre-processing, advanced recognition models, and language models that validate outputs by checking against likely word sequences. Still, no system is perfect, and accuracy remains a moving target, especially in high-stakes fields like law and medicine, where even minor errors can have significant consequences. Beyond recognizing characters, layout analysis gives documents their structural meaning. Most documents are not written in a straight line of text. They include headers, subheaders, paragraphs, footnotes, and multi-column layouts. Layout analysis detects these elements, identifying which lines belong to which sections and how blocks of text relate to one another. For example, identifying that a line is a heading changes how the system interprets the following content. Distinguishing between body text and footnotes helps separate primary from secondary information. Layout parsing essentially reconstructs the architecture of the page so that the extracted content reflects not just words, but their organization. This is comparable to how humans read newspapers, not by scanning linearly across every column, but by recognizing distinct sections, headlines, and article boundaries. Layout analysis is what makes machine reading reflect this human ability to navigate structure. Tables within documents present a particularly unique challenge. Tables often carry dense, structured information where meaning lies not in individual words but in their arrangement across rows and columns. Identifying headers, aligning cells, and preserving relationships are essential. For instance, a table of financial results may include quarterly revenue figures aligned with specific divisions. Simply extracting the numbers without the correct alignment would create nonsense. Document intelligence techniques identify these relationships, reconstructing table structures so that rows and columns remain intact. They may even convert tables into machine-readable formats like CSV files for integration with databases. Handling tables well turns static documents into dynamic data sources, enabling analysis at scale. For organizations, accurate table parsing means unlocking insights from thousands of spreadsheets, reports, or filings without manual effort. Forms and structured fields pose another distinct opportunity and challenge. Many industries rely on forms to collect information: loan applications, medical intake forms, tax documents, or shipping invoices. These are designed with fields where specific values must be extracted, such as names, addresses, dates, or account numbers. Document intelligence systems specialize in identifying key value pairs, mapping the labels on forms to the user-entered data beside them. For example, recognizing that invoice number 5,482 inches maps 5,482 as the value of the invoice number field. Specialized algorithms are needed because forms vary widely in layout and format. Success depends on detecting not only the text, but its role in the form. Automating this extraction saves vast amounts of manual data entry work, enabling entire industries to scale processes that once required armies of clerks or analysts. Atop the structural layer sits semantic understanding. Recognizing text and layout is important, but real value comes from interpreting meaning. A contract clause about liability is not just text, it carries implications for legal risk. A patient's recorded allergy in a medical form is not just a field, it is a safety-critical piece of knowledge. Semantic interpretation allows systems to move from "what does the document say" to "what does this mean in context?" This requires language models that can parse legal phrasing, financial terminology, or medical vocabulary, grounding extracted text in relevant knowledge. By adding semantics, document intelligence shifts from being a tool for transcription to one for comprehension, making it useful for decision-making, compliance, and strategic analysis. Modern systems increasingly combine vision and language to handle documents more effectively. Vision models interpret layout, structure, and formatting, while language models interpret meaning. Together, they form multimodal systems capable of reasoning across both dimensions. For example, identifying that a block of bold text at the top of a page is a title requires visual analysis, while understanding its significance requires language analysis. These hybrid models are often pre-trained on large corpora of document images and text, then fine-tuned for tasks like invoice extraction or contract review. By combining modalities, they capture both the form and the function of documents, reflecting the reality that documents are not just text, they are visual artifacts with meaning encoded in their structure. Applications in enterprise environments illustrate the growing adoption of document intelligence. In legal departments, systems review contracts for risk clauses, saving lawyers from wading through repetitive boilerplate. In finance, banks process loan applications automatically, verifying details and checking compliance. In healthcare, systems extract key clinical information from handwritten or scanned medical forms, supporting electronic health record updates. Regulators rely on document intelligence for processing filings at scale, ensuring traceability and consistency. Each application demonstrates that documents are not barriers but opportunities for efficiency when machines can read them as effectively as humans. Document intelligence provides the leverage needed to handle overwhelming volumes of paperwork, freeing professionals to focus on judgment rather than transcription. Compliance benefits reinforce the business case for document intelligence. Many industries are bound by strict regulations that require documentation of decisions, processes, and transactions. Manual handling is error-prone and difficult to audit. Automated systems provide consistent extraction, structured logs, and traceable records, supporting both efficiency and accountability. For instance, in pharmaceutical regulation, accurate document processing ensures that submissions meet formatting standards and contain required details. In banking, automated extraction supports anti-money laundering efforts by ensuring that customer data is consistently captured and cross-referenced. Compliance is not just about meeting rules, it is about being able to demonstrate compliance reliably. Document intelligence offers both precision and proof, reducing risk while building organizational confidence. Evaluating document intelligence systems requires rigorous benchmarks. Accuracy must be assessed at multiple layers: OCR transcription quality, layout parsing correctness, and semantic extraction reliability. Benchmarks such as FUNSD for form understanding or DOCVQA for document-based question answering provide structured ways to compare systems. Evaluation ensures that claims of accuracy translate into real-world reliability. Without benchmarks, systems may overpromise and underdeliver, eroding trust. With them, organizations can make informed decisions about which tools to adopt. For industries where mistakes are costly, such as law or medicine, benchmark-driven evaluation is indispensable. It turns abstract performance claims into measurable guarantees. Despite advances, current tools face clear limitations. Complex layouts, such as multi-column legal documents or nested tables, remain challenging. Handwritten text, with its variability and unpredictability, continues to resist reliable extraction. Low-quality scans exacerbate errors, particularly in older archives. These limitations mean that document intelligence systems still require human oversight, particularly in high-stakes workflows. The frontier of research is pushing into these gaps, but enterprises must deploy with realistic expectations. Document AI is powerful, but it is not infallible. Understanding its limits ensures that organizations use it responsibly, leveraging its strengths while mitigating its weaknesses through hybrid human-machine approaches. Integration with knowledge bases demonstrates the practical value of document intelligence. Extracted information rarely stands alone. It typically feeds into larger enterprise systems. A contract clause may enter a legal knowledge base for precedent analysis. An invoice entry may feed into a financial system for reconciliation. A regulatory filing may populate a compliance dashboard. By connecting document intelligence outputs with knowledge bases, organizations turn unstructured data into actionable intelligence that informs strategy, operations, and compliance. This integration reflects the principle that information gains value when it flows into broader systems, where it can be queried, aggregated, and applied at scale. Bias and error risks remind us that document intelligence is not immune to inequities. OCR accuracy varies across languages and scripts, with non-Latin alphabets often suffering higher error rates. This disparity can create unequal access to automation, privileging some regions or industries over others. Errors may also disproportionately affect marginalized groups if forms or documents include non-standard names, dialects, or handwriting. Recognizing these risks is the first step toward addressing them. Designers must curate diverse training sets, validate performance across languages, and ensure equitable treatment. Without such efforts, document intelligence risks reinforcing global imbalances rather than alleviating them. Ethical deployment requires constant vigilance and an inclusive perspective. As we conclude this first half, it becomes clear that document intelligence is both a technical and organizational breakthrough. It combines OCR, layout analysis, table and form parsing, and semantic interpretation to make static documents dynamic. Its applications span law, finance, healthcare, and regulation, providing efficiency, compliance, and insight. Yet it also faces challenges of accuracy, bias, and complexity that require ongoing attention. Document intelligence is not just about reading documents faster. It is about transforming them into reliable, actionable knowledge that supports enterprise goals. It lays the foundation for the next step in multimodal AI, moving from reading documents to creating and editing them in ways that extend intelligence beyond interpretation into active authorship. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Document intelligence is increasingly central to legal workflows, where professionals must review vast numbers of contracts, case files, and regulatory submissions. Traditionally, lawyers and paralegals have had to manually comb through pages of text to find clauses about liability, confidentiality, or payment terms. Document intelligence systems now automate much of this initial work by extracting key sections, highlighting relevant provisions, and even comparing terms across multiple contracts. For example, an AI-powered tool might automatically flag clauses that deviate from a company's standard risk language, enabling legal teams to focus their attention on what truly matters. In case review, systems can quickly sift through thousands of scanned documents, identifying which ones are relevant to a specific dispute. This not only saves time and cost, but also reduces human error that arises from fatigue. Legal professionals can then direct their expertise toward analysis and negotiation rather than repetitive reading, making the entire process more efficient and strategic. Healthcare applications of document intelligence are equally transformative. Hospitals, clinics, and insurance companies deal with massive amounts of unstructured data in the form of medical records, intake forms, prescriptions, and lab reports. Extracting and organizing this information is critical for accurate care and timely billing. Document intelligence systems can read handwritten notes from physicians, identify key details like allergies or medications, and populate structured electronic health records automatically. They can also process insurance claims forms, detecting errors or missing information before submission. This reduces administrative bottlenecks, ensures faster reimbursement, and improves patient safety by minimizing transcription errors. For clinicians, it means more time focused on patient care rather than paperwork. For patients, it results in smoother experiences, with fewer delays caused by lost or misinterpreted information. Healthcare demonstrates not only the operational value of document intelligence, but also its potential for direct impact on human well-being. In financial services, document intelligence streamlines operations that once required entire departments of clerks. Banks, for example, process loan applications, tax forms, account statements, and regulatory filings at immense scale. Document AI systems automatically extract borrower details, validate supporting documents, and check for compliance with anti-money laundering or know your customer regulations. They can also process investor reports or credit card statements, identifying anomalies that may signal fraud. By automating these tasks, banks reduce manual labor costs, accelerate approvals, and improve accuracy. Compliance departments particularly benefit, since document intelligence can flag irregularities in real time, helping institutions avoid fines or reputational damage. In investment contexts, document intelligence allows analysts to process corporate filings or financial disclosures rapidly, ensuring timely decision-making. The result is a financial ecosystem where documents are no longer bottlenecks but enablers of efficiency, transparency, and regulatory accountability. Cross-language OCR expands the reach of document intelligence to global operations. Businesses operating internationally encounter documents in multiple languages and scripts, from English and French to Chinese, Arabic, and Hindi. Traditional OCR systems often excel in Latin alphabets but struggle with cursive or character-based scripts. Modern multilingual OCR addresses this by supporting a wider array of languages, ensuring that global enterprises can process documents consistently. For example, a shipping company may handle invoices in dozens of languages, requiring accurate extraction of key fields regardless of script. Cross-language OCR also supports government agencies that process immigration documents or multinational companies that manage global contracts. By broadening coverage, document intelligence systems empower organizations to unify their operations, reduce regional disparities, and create more inclusive automation. Language diversity is no longer a barrier but an integrated part of enterprise document workflows. Integration with retrieval-augmented generation systems demonstrates how document intelligence connects with broader AI ecosystems. Once documents are digitized and structured, they can be indexed and fed into retrieval systems that support natural language querying. Imagine an employee asking, "What are the penalty clauses in our supplier contracts?" Instead of manually searching through hundreds of PDFs, a retrieval system powered by document intelligence can locate relevant sections, extract them, and pass them into a language model that generates a coherent summary. This integration allows enterprises to harness the full value of their document repositories, turning static archives into dynamic knowledge bases. By linking document intelligence with retrieval and generation, organizations not only process documents but also enable reasoning over them, unlocking insights that were previously buried in paperwork. User trust and transparency are essential for the adoption of document intelligence. Automation can be unsettling if users do not understand what is happening behind the scenes. To build confidence, systems should present extracted fields and interpretations clearly, allowing users to verify results. For example, a contract analysis tool might highlight the exact text corresponding to termination clause alongside its extracted summary. In healthcare, showing which handwritten note produced a specific allergy entry reassures clinicians that the system is accurate. Transparency also allows users to correct errors, feeding improvements back into the system. This partnership between machine extraction and human oversight ensures higher accuracy and fosters adoption. Trust grows when users feel that systems are not black boxes, but clear tools that augment rather than replace their expertise. Transparency is therefore not an optional feature, but a critical design principle. Cost considerations shape the business case for document intelligence. Manual document handling is expensive, requiring skilled labor for tasks like data entry, review, and filing. Automating these processes reduces labor costs, speeds turnaround times, and minimizes errors that could carry financial penalties. For example, automating invoice processing reduces the need for large accounts payable teams, while contract review automation reduces reliance on external legal counsel. However, implementing high-quality document intelligence requires upfront investment in software, infrastructure, and training. Organizations must weigh these costs against the savings in labor and the potential for improved compliance and efficiency. In most cases, the return on investment is significant, since document intelligence not only lowers costs but also unlocks opportunities for growth by freeing skilled employees to focus on higher-value tasks. The economics of automation favor adoption, provided that organizations manage implementation wisely. Latency is another factor in large-scale document workflows. Enterprises often process millions of documents daily, from insurance claims to shipping manifests. If each takes even a few extra seconds, delays accumulate rapidly. Document intelligence systems must therefore be designed for scalability and speed. This may involve distributed processing pipelines, parallel OCR, or cloud-based scaling strategies. The goal is to keep processing times low while maintaining accuracy. For instance, a bank cannot afford to delay loan approvals by days simply because its document AI system is slow. Latency considerations also affect user satisfaction. Clients expect immediate results, not delays caused by back-end inefficiencies. Balancing accuracy with throughput ensures that document intelligence supports, rather than hinders, enterprise operations. Speed is not just a convenience. It is a necessity for systems operating at industrial scale. Security and privacy are non-negotiable when dealing with sensitive documents. Many documents processed by AI contain personal, financial, or proprietary information. Protecting this data requires encryption at rest and in transit, strict access controls, and auditing mechanisms. Compliance with regulations such as GDPR or HIPAA is mandatory in industries like healthcare and finance. Document intelligence systems must therefore be designed with security as a core feature rather than an afterthought. This includes ensuring that extracted data is stored responsibly and that access is limited to authorized personnel. Without strong security, automation becomes a liability, exposing organizations to breaches, fines, and reputational harm. By embedding privacy and security into the architecture, organizations ensure that document intelligence enhances trust rather than eroding it. In sensitive industries, secure automation is the only acceptable path forward. The future of document intelligence lies in research that pushes beyond current limitations. Zero-shot document understanding is one emerging direction, where systems interpret unseen document types without task-specific training. Another frontier is handwriting recognition, which remains challenging due to variability in style and legibility. Advances in multimodal pre-training promise improvements by allowing systems to learn from both text and layout simultaneously, strengthening their ability to handle diverse formats. Researchers are also exploring methods to reduce bias, improve multilingual OCR, and integrate document intelligence more tightly with enterprise workflows. These developments will move systems from being specialized tools toward general-purpose document readers, capable of handling virtually any format presented to them. The trajectory points toward more robust, adaptable, and universally useful document AI. Benchmarks provide the structure needed to measure progress in this field. Datasets such as DOCVQA, which evaluates question answering over documents, and FUNSD, which tests form understanding, provide standardized challenges for comparison. Benchmarks test not only OCR accuracy, but also layout parsing and semantic extraction. They allow developers and organizations to see where systems excel and where they struggle. For instance, a system may perform well on clean digital documents but falter on handwritten or poorly scanned ones. Benchmarks highlight these gaps and drive innovation to close them. Without benchmarks, progress would be anecdotal and unmeasurable. With them, document intelligence becomes a science with clear milestones and transparent progress. Evaluation is not a peripheral activity. It is the engine of improvement in this rapidly evolving field. Integration with intelligent agents extends the usefulness of document intelligence. Agents can automate entire workflows by not only reading documents, but also acting on the extracted information. For example, a document agent might process an invoice, enter the extracted data into an accounting system, and trigger a payment request automatically. In legal work, an agent might extract key clauses from a contract, cross-reference them against company policy, and draft a report for a lawyer's review. In healthcare, an agent might read a patient's lab results and schedule follow-up tests if abnormalities are detected. This integration transforms document intelligence from a passive extractor into an active participant in enterprise workflows. Agents make document AI actionable, turning information into outcomes. Industrial trends confirm that enterprises view document intelligence as a cornerstone of digital transformation. Companies in every sector face pressure to process ever larger volumes of information with greater accuracy and efficiency. Manual methods cannot scale to this demand. Document AI is therefore becoming critical infrastructure, much like databases or networking systems. Organizations that adopt it gain competitive advantages in speed, compliance, and insight. Those that delay risk falling behind as competitors automate. The trend is clear. Document intelligence is not a niche capability, but a mainstream necessity for modern enterprises. Its adoption signals the shift from paperwork-heavy processes to digital-first operations. Research continues to advance accuracy and usability through multimodal pre-training. By training models jointly on text and layout, researchers achieve systems that understand not only what words mean, but also how their placement contributes to meaning. This is particularly important for complex documents like legal filings or scientific articles, where structure guides interpretation. Multimodal pre-training improves performance across diverse tasks, from table parsing to semantic extraction, making document AI more robust. As research matures, these improvements will translate into commercial systems that handle a wider variety of document types with greater reliability. This ongoing progress suggests that document intelligence is still at the beginning of its potential, with much more to come. As the discussion closes, it becomes clear that document intelligence is not merely about reading documents, but about transforming them into structured, actionable knowledge. Its role spans law, healthcare, finance, and beyond, making it a universal enabler of efficiency and compliance. By combining OCR, layout analysis, table and form parsing, and semantic interpretation, these systems unlock value from information that was once static and inaccessible. Yet challenges remain: accuracy, bias, scalability, and privacy must all be addressed. Future research promises advances in zero-shot understanding, handwriting recognition, and multimodal pre-training. Integration with agents will push document intelligence further, turning passive extraction into active automation. This evolution sets the stage for the next frontier, moving from interpreting documents to generating and editing them, extending multimodal AI into the creative domain. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.